Hej, jeg kan ikke høre jer, men kan I lige bekræfte, at I kan? Hello, everyone, and welcome. Nice to see a lot of people checking in. If I can get someone to confirm that the audio is going through clearly, that would be really amazing. Um, Welcome to everyone. My name is Frederica, and I am the community manager here at UPRI. That means that I help orchestrate these webinars with primarily, thank you, with primarily Jakob, one of our founders. And yeah, we have an interesting topic here today. Thank you as well, David. We are going to talk a little bit about, or a whole lot about, GxP compliant temperature mapping protocols. And yep, we have two of our co-founders, Jacob, as I think if any of you have been in our webinars previously, you have definitely seen him before, and probably also Adam, also one of our co-founders. They'll be giving an introduction to who they are a little bit later themselves. I'll let them take care of that. But in the meantime, we would love to hear where you guys are checking in from. We have a bunch of different countries represented. So if you don't mind letting us know which country you're watching from, we always We always find great joy in that. So yeah, we would love to hear more about that just for a few minutes before we kick things off.
Hello and welcome, everyone. Nice to see you all.
Good afternoon, good morning,
Yeah,
and good evening. It looks like we're all over the world already.
yeah,
Yeah.
absolutely. So we are very excited to have this webinar today regarding how to do GxP related or mapping protocols for the GxP industry. It's a very heartfelt topic for both of us, and we have a lot of experience working with different GxP industries in all regions of the world. So yeah, we're truly excited to get started today.
Yeah, and as always, I'm joining you here as the one asking the questions, and then Jakob, you're just gonna deliver the answers, right? And
Hopefully, yeah.
no, it's always like that.
Yeah.
And by the way, I joined in on I would say on a last seat because it was actually Mads that you were expecting to see here, but I got the chance again. So thank you very much for having me, Jakob.
Absolutely.
Yeah, that's kind of we reverse the hosting role here, and it's also Jakob who's doing everything on the technical side. So we typically call it he's DJing it in the right.
Yeah.
So you can do all sort of cool stuff with like pulling up banners and nice things on the screens for those of you who's actually looking.
Yeah.
But regardless, I'm really happy to be here, Jakob.
Yeah.
Thanks for having me, and I hope that I'll ask some relevant questions for the audience again today.
Absolutely. Yeah. So yeah, just again, it's Adam and Jacob here guiding you through this today. But I think Adam, you can maybe if you can just give a small brief introduction of to what kind of company are we and why is that important?
And I'm just going back a notch, Jakob, because I have one thing that I need to mention every time I do this session with you, Jakob, and that's like Jakob and we started up UPRI 12 years ago now.
Yeah.
Right?
Yeah, something like that.
Yeah, cool. And we've been going on strong for a very long time and really geeking this out. My own role here is I founded a company together with Jakob. I run as our commercial officer today. I'm living here in Denmark. I have two kids, a Volvo, and I don't have a dog yet, but that's kind of next step in that part. And I'm joining you, Jakob, one of my like star engineers of my life. You have a space engineering background, electronic engineering, and then you just fell in love with quality and compliance and metrology. Yeah. And to be honest, what you, Sigurd, Noam, and Christian has been doing since we started up this company is just remarkable. I'm so impressed. And it's just like we just got so much to show of all these inventions. Like I would dream about all of you out there actually just visiting us in our Copenhagen office and then joining us to see how our calibration lab is actually working. It's just so cool. It's fully automated and everything. But yeah, that's Jakob, and that's why we can talk about this topic. So welcome, Jakob.
Thank you very much. Yeah. I think just as a small intro, why does it even make sense that we're talking about this here today? We are from UPRI, and our mission has always been to be a one-stop solution for temperature compliance, also humidity, relative pressure, CO2. There's other things.
It just works better on Google, right?
It's I think, and also the most of what we're going to talk about today is also going to be circled around temperature compliance, because it's really one of those things that we see there's a lot of questions regarding, and it's also the primary factor or the primary environmental factor to measure in a lot of GxP industries. We do also have relative humidity and so forth, but we strive to supply our customers with everything that's related to compliance, environmental compliance or temperature compliance, both in terms of validation, as we're going to talk about today, where mapping is one of those categories, but also in the monitoring and the calibration fields. But I think without further ado, let's get right into just a bit. I sat down and had an idea of sort of what should be the agenda today, and I think there's only two parts to the agenda today. Firstly, we're going to talk briefly about what the mapping process is. We have done more than 20 webinars on various topics, including mapping. So if you're more interested in the entire process, I would advise on going back and seeing those. But we're just going to talk briefly about that today. And then we're basically today going to focus in on the mapping protocol, which is really the guiding star for how to perform a temperature mapping. It's where we get everything sorted out. We plan out all the different items that we're going to go through. So that's also where we see the most questions being, because that's the most unknown for a lot of our customers. That we help through this process. How do you define what your requirements are? What should be in the protocol? And I would put my hand on the stove and say that if you do your protocol well, the rest will sort of come naturally with the execution of it and the reporting afterwards. So for me, my honest opinion is that the protocol is the most important part of any mapping study, because you plan out and you define exactly what is to be mapped and how it is, and also how you plan to report on the findings. But we shouldn't get ahead of ourselves here. So
and then just before we go forward, because we know that that you guys out there, you most likely have 1 or 2 or 3 or 100 questions, and you're very welcome to just share them in the audience chat. We'll try to take them up while we go, but we will try to really maintain a short Q&A in the end. We're just taking up slightly more complex stuff, maybe that needs a touch also.
So shoot ahead with the questions during that. We're always happy to have some questions in. It also helps us steer in the direction that's most interesting to you.
Yeah, and you should kind of like look at this as a fireside chat, or like you're welcome into our like small dining room of some sort, and then we just have a chat. So be completely free to ask questions. And if you're a bit not interested in I don't know, sharing your personal information in the audience chat while you ask a question, you're also free to just write me an mail during the webinar, and then I'll take it up and make sure that I don't mention any names, because that may also be, I don't know, something that would be relevant for you guys to just get an answer on your question without actually sharing your name and place.
Absolutely.
Right. So I'll just share my mail here.
Yeah, perfect. But moving on, as promised, just a brief insight into the mapping process. And I need to start out by saying that the mapping process, although there are several different guidelines, which we're not going to touch that much on today, there are the main guidelines in terms of WHO and ISPE, and you can look those up. We're not going to talk so much about the different guidelines today, but I want to say that all the approaches are pretty much the same. So independent on whether you're performing a mapping for a GMP or for GDP or a GLAP, whatever it might be, the same process applies. But there's one thing that we often see is a bit of confusion as to where does mapping fit in terms of the whole process validation line of thought. And the way that we like to set it up is as I've shown here in the picture. If you look at a classic V model, we have on the left our requirements phase and our risk analysis, and that's basically going to be where we define our protocol as well. During the right side of the V, the operational qualification and the performance qualification is really where mapping comes into play. Mapping, in my perspective, is a qualification exercise. So normally we would like to say that operational qualification is empty and performance qualification is full. It's not entirely wrong to say so, and it's not entirely right, but it's pretty much a good rule of thumb that if you consider mapping a part of validation, and should also be part of your validation master files and so forth, you're really fine in terms of understanding the approach. The mapping process basically consists of 3 steps. There's the protocol stage, which we're going to talk about today, where we define exactly what we are mapping, how we're planning to do it, what the requirements are, what the methodologies are, and so forth. We'll get into a lot of different topics today. That is followed by the execution phase. So that's actually where you set up the data loggers. You gather the data, you do the different types of tests, empty, full, door opening tests, power failure tests, loading tests, offloading tests. There's a whole plurality of tests to be performed. And that's followed by the reporting phase, where we gather all the data, we analyze all the data, and we write our conclusions and our recommendations for continuous monitoring. But those are the topics. Those are a topic for a whole other webinar. But today we're going to focus on the first step, which is basically the report, the protocol. Sorry, not the reporting. I also want to mention one of the questions we often get is there a difference as to whether you're mapping a warehouse, a fridge, a freezer, a reefer, whatever it might be, walk-in rooms, and the basic approach is the same. So often we like to, in these webinars, take a warehouse as an example, but that's just out of convenience because the scales are larger. It's easier to explain the positions and so forth. But the same approach can be applied to various sizes of temperature controlled units, whether they be from very small incubators, for example, up to very large warehouses. So the approach is the same and the methodologies are the same. So those can really be applied across the field.
What about if, like, maybe
Mm,
just a tricky
mm,
question, like what we're talking about an autoclave or something like that, like high pressure. It can both be super
mm.
big, but also sometimes not that big. Is
Yeah.
it the same
The,
methodology
the, the,
still?
the methodology is the same.
Oh,
There's often a little bit more of technical issues in terms of getting sensors
ah,
in and out of autoclaves, especially
yeah,
because
yeah.
they're
And then
high
having some
pressure.
sort of a grid kind of installation within, and how
Yeah,
you, yeah.
exactly. But if you, and that's also one of the things we're going to promote today, the risk-based approach to placing sensors and how to which kinds of tests to conduct and so forth.
Mhm.
The methodology is the same, and that's also going to be one of our points today. Is that a lot of the guidelines that have been written, I'm specifically focusing on the ISPE and the WHO technical series guidelines. Those are pretty much focused on rules of thumb. So basically, how you should place them, but the underlying risk assessments that those follow that we're going to explore today, you can basically apply those to different scenarios, and you will get to the same result as the guidelines have.
Mm,
That's my theory at least.
cool.
Yeah, so really trying to move in. I've taken out a few of the topics that should be in a, or at least should be considered in a mapping protocol. I've not done an exhaustive list. I think the guidelines do a very well job of that. But I think just for starting out, there are some baseline requirements, and I think for anyone working in the GxP industries, this should not come as a major surprise. But we do see some cases where the fundamentals have been forgotten. So first of all, an approval page, you should have approvals, various who's the author, who's the reviewer, um, uh, who's approving the protocols. Do you have any SMEs in who's taken into account doing this? I think it's pretty much basic stuff for any type of validation exercises. Acronyms and glossary. I think that's actually one of the things you have to be sort of remembering, that when we're talking mapping exercises, we have a very large scale or variety of people who need to read and understand this report. So you have all the way from very technical and maybe even operational staff who needs to take the recommendations from the report, perhaps, or maybe the ones who are going to perform the mapping, and all the way up to quality people who might not have the same sort of understanding of what is an HVAC system, for example, or what is a condenser and so forth. So having a good acronyms and glossary sometimes helps because not all people are subject matter experts in the field of temperature mapping. Um, References again. One of the things we often see actually is that companies have followed certain guidelines in terms of how they've developed their mapping protocols and their mapping reports and the whole test strategy, but they've forgotten to include the references. Often, and I'll get on that wagon as well. I'm guilty as charged. Sometimes we tend to focus on the internal guidelines, and that's great as well. But in terms of mapping, it's such a harmonized field. There are so great guidelines on the topic. So we might as well be clear on terms of which strategies that we follow and which guidelines that we follow. It also makes it a lot easier for the auditor afterwards to sort of evaluate your report based on that. Roles and responsibilities. Again, in a mapping exercise, it can be very physical if we're talking large warehouses. So you might have some people responsible for authoring the mapping protocol, and you might have others that are responsible for ensuring that all loggers are set up correctly. And we sometimes see that those are different people, but we just need to have that outlined so we're clear also as it comes later on in terms of training, how to ensure everyone is aligned. Um, Document IDs is just the number of times we've seen people forgetting that these are controlled documents. These should be reviewed and so forth. So please remember a document ID. And also change history. We often see mapping protocols going through a lot of revisions. And sometimes, if we're not strict in terms of keeping our change history up to date, whenever we release something for reviewing, those can get mixed up. Because what we often see, let's say for larger warehouses, is that you need to align your testing with operational staff. You need to let people know that you're shutting it down for, is it 5 days, is it 2 weeks, whatever it is, to perform your mapping. And therefore, there's often a lot of revision history in these types of documents, in protocols, because it's a lot of different people's opinions that needs to be taken into account, and expert knowledge in terms of what is relevant. Is it normal behavior that we're opening and closing the door 10 times a day, 20 times a day? And a lot of these questions will sort of just be generated along the path. So having a strong change mentality and a strong change history is really important.
Jacob, that's why I really, really love this particular webinar, because it's kind of like the examples you give on something that is not just basic, but it's kind of like a part of every scientific approach and review that you do. That you kind of have this kind of scientific approach and there's theory, but it's so mixed up with reality. All the examples that you give here is like it's purely like confronted with the baseline in reality. And again, you could keep on coming with examples of how easy it actually is to mess this up. And the examples that you give when you just add, like now you just talk about it in this kind of like super easy setting that you have one fridge or one warehouse that you actually then need to follow these basic requirements. But what happens if you have a global setting with warehouses all over the world, and you have different people, different operational staff that then reads this differently? This is the examples that you see on a daily scale, right?
It's really one of those exercises where it takes it to the extreme in terms of defining requirements on a very quality-like level, all the way down to people who will literally get their hands dirty setting up loggers if we're talking large warehouses. So there are a lot of different things to consider.
And just handwriting, like making sure that you can read the handwriting afterwards.
Absolutely,
right?
Yeah. So we'll also come into that in terms of training, but
sure.
It's really no problem. But it is really one of those core things where you need to have a great understanding of who is going to perform it, both who's going to write it, and that it's as you said, it's written in a language where all the people who are going to participate in the exercise can read it and understand it to a high level.
Yeah, because you're really just gonna get a massive bunch of issues down the line if you don't do it right.
Absolutely, absolutely, yeah.
Cool.
Yeah. But then those are sort of the baseline requirements, and the other topics that I've taken here are going to be more focused in terms of what are some of the experiences we have and some of the knowledge that we'd love to share with you. So having a great purpose is actually quite important, because we want to answer the question, why are we doing this? And you might say, well, to get compliance. And that might actually be just enough purpose. But it's really important that we state what our purpose is, because we need the reader, which might often be the auditor, to understand, was this a first-time exercise? Was this to initialize it? Was it because of a remapping? Was it because of a change? And what requirements are we trying to achieve with this? There might be some regulatory requirements that we're trying to show compliance with, but it's just really, really important to have a purpose, because it really gives the foundation for why is this even relevant. The other part which we often see lacking a bit is it's also in terms of having this approach where you might have a lot of different scenarios in larger organizations, is a really good description of the facility or the equipment that we're mapping. We need to know what we're dealing with, and as precise as we can do it, the better. And it's not only to mention that it's a freezer or it's a warehouse. We need to have more thorough descriptions, which we'll use later on when we get into the risk assessment stage. So we need to have an idea of the dimension. Those are sort of the baseline. How big is this? Often you'll get lost in floor plans or fridges or freezers, whatever it might be. Often fridges and freezers are sort of the same size, but having a really good idea of, especially like larger warehouses or walk-in rooms, how big are we talking? How wide, how long, and what is the height of it? That's really, really important. And we also need to have a good understanding of the external influences. And that's really one of the pitfalls we see, is that We crop the floor plan to the room we're very interested in mapping. But when you get to it as a reader or someone who needs to take into account the risks associated, if you have no idea of what's around it, it's almost impossible to do risk assessment. Great examples of this is if you have walk-in rooms that are placed inside larger buildings that might be temperature controlled. Or on the other hand, are we talking large warehouses where the outside walls are exposed to the outside air? There's a world difference between those two. Because if you have air around the unit that you're trying to map that is controlled, well, then we might say, as we'll get to in the risk assessment, we don't need to perform a winter and a summer mapping, because we can sort of assume that and often you would do measurements as well to confirm that the external influences are the same, whether it's winter or summer outside. But on the other hand as well, do we have adjacent rooms that have a totally different temperature? So we often see these large warehouses. There's a separating wall separating cold storage, which might be 2 to 8 degrees, and ambient storage, which is 15 to 25 degrees, or even freezing, which is minus 20 degrees. So you might say, why is that relevant? We'll map it anyway. Well, doing a power failure study, for example, there's a larger risk that if you have a great temperature difference, that those two rooms are going to affect each other. And if there's a connecting door, well, there might be a risk that if that's not automatic, or however long it might be open for, that you'll have non-conformant air slipping between those two. But it might also be windows, both in terms of like horizontal and vertical windows. Are those blinded? Are they not? Where are the access gates and doors? Where do people come in and out from? It's really good idea to have a really good understanding of how that's built. And if we take into smaller units, how is it built? Which kind of control system does it have? I could go on talking about external influences and describing it, but it's really important to understand that you need a thorough understanding. Otherwise, it's impossible to assess whether the risk assessment you did is sufficient. If I am to review, and we often see this if using like external company like ours, we do a lot of these mappings, we do hundreds of year, if not almost 1,000. But if we can't have an idea of what exactly how it looks and what the external influences are, it's impossible to say whether that will have an impact or not. And sometimes that gets lost in translation if you have one role authoring it independently and another role reviewing the protocol independently.
Isn't that just super problematic in a company? You really want to streamline your protocols and stuff like that.
I mean, Adam, I'm afraid to tell you something called the real world. I don't know if you heard about it, but yeah, of course, in the ideal world, you would sit next to each other, would have sort of reviewed the same things, but we just see in a lot of practical real world examples, it's just not possible. It might be due to different geographies. You might have a central QA unit and a remote, let's say a GDP center somewhere, or distribution center somewhere. Those roles might be separated. The SME might sit in another country, and that's why it's so important that we as quality people, we enforce that we want to have all these things described. Yeah, and just one other thing is in terms of temperature control, it's important to describe how the unit is temperature controlled. For fridges and freezers, it's almost the same, but for warehouses, where they're situated, how do they work? Do they work in tandem or independently and so forth? And then I think lastly, one of the things that people often forget is what is the daily operation? How much do you plan to use it? If we don't know that, well, then we can't test it during performance qualification. So performance qualification in a mapping, translated to a mapping scenario, is basically how do we test this under scenarios that would look as much as possible like real life use. If you do not have an idea of what the real life use is or real life operation is, you can't test it. I think all validation engineers listening in will have the same frustration as me. So sort of we need to have an understanding of this before we start anything. So the next thing is scope. That's really one of the things that people are actually quite good at normally. We need to understand what are we mapping and what are we not. Exactly which rooms are included, which units are included, which kind of mappings do we plan to do, both initial mapping and then a seasonal variation mapping. Which kind of test do we plan to have part of this? I think this is sort of the standards, but most importantly, what we get a lot of questions for is summer winter mappings. And I would say again, we'll get back into it in terms of the risk-based approach. But again, if you don't have the description, if you don't have a good description, then you don't know whether to do a summer or winter mapping.
Do you know why, Jacob, that, you said just that this is typically something that actually people they nail out there. Do you know why? Why is that?
Yeah, I think it's because there's a very large resemblance to process validation again, right?
Okay.
Well, and all other quality documents basically as or exercises is we need to have a really good understanding of the scope. I would say where we see the industry where we see most struggling with defining good scope is where you're not that used to the whole validation line of thought.
Right. It's because it just matches the role of being in validation, whereas some of the other parts here is much more, I would say, specific to this task.
Yeah,
Mapping.
I think that would be
Okay.
yeah. I would resonate with that exactly.
Mm.
Yeah, again, what areas are mapped? What processes are mapped? Again, is it we need to again to identify what is the expected use, and then those expected uses are part of our scope or are they not? That's really important. It's not impossible to map some processes out of scope, but we should not store sensitive products if we have those processes. Again, the objective, what specific things, I put in quote, do we need to find out with the mapping? Again, what is it? What is there a standard? Is there a specific list of requirements for my customer, perhaps, or internal requirements or external requirements that we're trying to show conformance with? It's just really important that we get that because it gives a lot of environment for when reviewing or authoring the protocol. We want to show the acceptable range of conformance. So basically, these are the settings that we're trying to show conformance to. We might also have what kind of variations in temperature, for example, can we accept? So these are basically our acceptable range. But is it okay? Do all temperatures need to be exactly within those limits? Can we accept smaller variations and so forth? We need to identify those things. And also, do we plan to show conformance during operation? I'll give you a hint. We normally tend to do because it's not much fun in having a fully compliant warehouse without being able to use it. Moving on to another topic, and we really touched based on this with your questions again there, Adam. So training is something that all guidelines pretty much explain in that you need to identify the need for training and also how you plan to conduct the training. We need to answer the question, who should be trained and how? And it's, I think, one of the reasons why a lot of these standards and guidelines, they emphasize that you need to formalize your training and when doing these exercises is because it's understood that there is a lot of different people on different understanding levels in terms of mapping that are involved in a normal mapping exercise. It's all the way from the people from quality assurance. We need to ensure that we're following the right guidelines and the right regulations and so forth, down to the people who are actually going to partake in writing protocols and reports and so forth, down to the people who will be conducting the exercises. So understanding that there sometimes might be a gap in understanding this process, because it is, as you mentioned, a process that both involves quite physical stuff and quite precise documentation. We need to be able to identify what kind of training and competencies do each step need. And what we often see, and we also use a lot, is basically defining, well, the people who are authoring and reviewing the protocol and report, for example, need to have this and this competencies. They need to have at least a year of experience, or they need to have understanding of the guidelines. And the people who are conducting the mapping needs to have a good understanding of ALCOA principles, for example, to make sure that we have a good traceable documentation, and also need to be able to understand the floor plan and how to set up the different systems. So it could often be sort of going from reading the protocol all the way up to having system knowledge, like the system you're using for your mappings. Do you understand how that works? So if you encounter any differences from the protocol when you're on site, to evaluate whether those will have an impact on the protocol as well.
What do you actually mean by system? Is that, the applications
Yeah,
or
like the data loggers and
right?
the system, the sort of bit of metrology understanding in that as well. So
Mm-hmm.
one of the great examples that we've seen out there is, for example, often you would need to, for practical reasons, to move a sensor.
Mm-hmm.
Just a little, because I always like to say, when we're sitting nice warm in our offices and with our computer and a hot coffee, it's very easy to say, oh, I want a sensor placed up in that corner up there. But then when you get on site, sometimes it's just impractical to get physically to that location.
Right.
And to have someone, it's always a good idea to beforehand having a good understanding of, well, the people on site, can they individually make a decision, of course assuming they document it, to move a sensor to a practical position, or who needs to make that evaluation before starting the mapping exercise. And that relates back to the training. It's really also about setting expectations of the people involved in the mapping exercise. What kind of training do they need to have? So there's a lot of great questions coming in. Just
Yeah, I was
keep
just
putting them
thinking
in.
about like taking one of
Yeah.
Francis. He have quite a few questions and super interesting. And one of them is related to training somehow, but it's about fluid dynamics.
Yeah, fluid dynamics is a really interesting topic. I would say, well, I can say that the mapping standards and guidelines out there are written and released with a mindset that you don't need to understand fluid dynamics. We're basically attacking this problem as a black box sort of issue, or white box, in terms of us understanding some of the inner workings and how this is of this process. We It's an emerging topic for sure, using fluid dynamics to sort of estimate where hot and cold spots might be,
Mm.
but it's not required. I'll say that. I think we can do a whole webinar on fluid dynamics for temperature
Yeah,
mapping.
because we are really like dipping our toes in it these days.
Absolutely.
Figuring out because there are some certain advantages with it, right? That you can
Uh,
simulate certain
yeah, but
certain
I would say as well that having a good understanding of, and I think from my own perspective, this really came from experience.
Mm-hmm.
Like, how fast does hot air rise?
Mm.
Like, if you have a cold storage and you open a door out to a,
Yeah.
let's say, warmer area, you sort of start to get the understanding of how far and how fastly does that air enter the room.
Mm.
But when we get back to the risk assessment as well, I would say that having just a basic understanding that, cold air, it goes down, hot air goes up, you should be pretty far in terms of,
Yeah.
of estimating the impact.
Because it's also like extremely complex. I remember in school, at least, that was tough.
Yeah, that is really tough. But
Yeah.
but a basic understanding of how
It's
air
fine.
moves. And also, one of the things I often like to do when I get out there is just lick my finger, put it up. Can I sense any sort of drafts? Well, have we considered that there might be a draft here in terms of how the HVAC system works? Well, we should probably mitigate this by placing an extra sensor in those locations. Yeah.
Right. Thanks.
Yeah. So another part we touched base on this before is, but in order to formalize the definition of what our acceptance criteria is, we need to be able to answer the question, what can we accept? So I'll bring it up again, but there is no such thing as an ideal warehouse, fridge, freezer, whatever it might be. It's the real world hits you hard if you believe that. Often we tend to identify our acceptable range. So that's basically, where do we want our temperatures? It could be relative humidities as well. I need to mention that as well. Where would we like them to be? And often, let's say in a cold storage, that might be in between 2 and 8 degrees. But often we do see that if you open doors, or just due to natural fluctuations of people leaving and entering, or goods leaving and entering, you will have fluctuations that will affect, or at least try to, or will often go outside those limits. So often what we advise on is upfront define what kind of excursions can we accept, because they will be there almost entirely for sure. And having taken that discussion up front, like how much of excursion can we accept and for how long, you'll get much easier through the report. Otherwise, afterwards, in the constant monitoring as well, you'll get tons of alarms if you're not really taking that discussion up front, either internally, if that's your requirements, or with customers, or a combination of those two. It's really important to understand that nothing is ideal, but it's a good idea. And we always, it doesn't have to be very complicated. Often what we would do is say, well, our ideal temperature range is 2 to 8 degrees, and we can accept temperatures between 0 and 2 degrees and 8 and 10 degrees for up to 30 minutes. You'll get 90% of the way there. You could do a lot of other, you can do mean kinetic temperature and so forth, but it becomes more complicated. But 90% of the way is just saying ideal range and what kind of excursions, both in terms of absolute temperature and in terms of time. You'll get very far in terms of defining your acceptable range. So now we get to the real interesting part, at least for our view, which is really the risk assessment. So if you have done all the previous items and you've been good at describing exactly what is the scope of this, how is the unit, let's say warehouse in this example, how is it built, what are the external influences, how do we plan to use it, which kind of training do we have, what's our acceptance range, you can really start to apply your risk assessment. We've developed a model here in GxP that we like to use, where we say there are typically 3 types of risk, and the first one is compliance risk. So what does that even mean? Well, we say often in these guidelines there are suggestions for where to place sensors and how many sensors and how far between and so forth. Often in real life, if we take the WHO guideline as an example, that's way too many sensors. But that is a risk. It's a risk that we're not following the guidelines per se, or you might be deviating in some points. Those are risks that need to be described. So we have good rationales as why did we deviate from the guidelines. The second one would be technical risks. So that would be everything that's related to technical installations. That could be doors. Doors is a technical risk. And you might say, well, if the door is just like an ordinary door that you can forget to close, well, that's a risk right there. If it has an automatic door system on, well, for how long does it stay open? That risk and quantifying that risk is going to tell us how we will plan our methodology. Because if we take a freezer as an example, well, if we know we're going to open that door 10 times a day for 30 seconds each, and it's just spread out through the day, that's what we're going to test. Because then we have a risk and we have a measurement of the mitigating action. The mitigating action is basically to measure it. Other types of technical risks could be forklift charges, doors, adjacent rooms that have different temperatures, the HVAC system where the blowout air and so forth. But again, we're relying on our previous steps of describing exactly what we want and how we're planning, or how we've described what we're actually measuring and what our objectives are. The last topic, or the last category, is what we call operational risks. There we're relying on how it's planned to be used. So that will be the number of door openings. It will be the process by which we're moving goods in and out of a warehouse, for example. Do you plan to move them in all at once? Do you have a staging area where you temperature equalize the products, or you're moving directly to storage? Are you using it for freezing in different types of products, cool boxes, whatever it might be? Those are operational risks related to how you plan to use it. And there you need a quite good understanding, to be honest, in terms of really being able to identify the risks associated with that. So applying these, the basic question we need to answer is, what are the risks and how should we mitigate them? That should really be, and that's what we'll get into in terms of the methodology. And this is another model that we've developed based on my personal view on what the guidelines say and how you should apply risk-based approach. So in the bottom here, there's basically the general placement recommendations from the guidelines. Although they do promote a risk-based approach, they basically also give you a lot of suggestions on where to place sensors. And in my opinion, those are based on risks. So if we understand, again, we talked about this before, if we understand the underlying risks, we'll probably get to the same conclusions, but we have a much better understanding of why we place sensors there. So taking the first one, the general placement recommendation is, well, you should have sensors in the corners, in the center, length, width, and height, and so forth. Well, the underlying risk is that we have a risk that not all positions have temperatures in the acceptable range. If I told you you need to have a fridge and you needed to ensure that temperatures were the same all over, or at least within the acceptable range, you would of course place them in the corners and in the center as to cover the whole volume. But that's not what they're saying in the guidelines. You might have, let's say, placement near heat or cold sources. Those could be technical risks. Well, they say, oh, you need to place it in the blowout air of the HVAC system. Why? Well, because we might have local heat or cold conditions or zones. The blowout air from the HVAC system might not be conformant. So in that way, if you look at the three categories of risk that we're dealing with, and you would say, okay, my mitigating action is to place sensors in those areas in order to ensure that they are indeed in the acceptable range, you would get to the same conclusions as most of the guidelines do. They are great guidelines, don't get me wrong on this, but I think you'll get to a much better understanding if you use the risk assessment yourself.
It's kind of like a thing you've always talked about in here, Jakob. And is it still like, I remember it back in the days when you really like focused a lot on risk assessing all the time, because I imagine it's kind of like reading between lines.
Sometimes it is, and I think it's also a lot of the guidelines are due for review because of the latest almost decade introduction of the risk-based approach. They do promote it. Auditors are really open to, and I think also very happy to see risk assessments. And again, they'll often come to the same conclusions at the mapping guidelines. But I think the flexibility of the mapping process becomes bigger if you understand that it's because of an underlying risk. And often you can remove sensors as well, because which is often a cost-saving little exercise, but because you can simply argue or rationalize that not all areas are risk areas. So just to give you an idea of what does this mean in practicality, I've pointed out some of these risk areas. So that could be HVAC system air, that's a risk. Gates, doors, forklift chargers, those are all different types of risk. And then the basic risks of not having homogeneity and variation of temperature within the acceptable ranges all through.
Nice. And yeah, I promised Frederica out there that I would just mention that afterwards we'll send out a mail, and in that mail there will be a link to Master's calendar where you can book a free of charge, just 1 hour check-in, no strings attached session with him, where you among other can talk about these, well, risk potentially or problems that you face out there. Well, see it as a helping hand.
Absolutely. Yeah. So some of the last steps here. So we've identified our risks. We've chosen how to mitigate those, which is often by placing temperature sensors. You could risk mitigate in the design states. That's not really what we're going to touch base on in the mapping process. But often you tend to risk mitigate by, either expanding the extent of the mapping tests or placing sensors, and often both. Then we need to identify the methodology. So how are we planning to test? And again, we're relying on all the specification and requirements we had from before. And that'll often be used to answer the question, how exactly are we going to perform this? And I have this small drawing in here which shows us what a typical mapping exercise would look like. So we'd often have some stability studies, would have some door opening studies, and this stabilization studies both in empty and full, and some power failure tests. I've written OQ up here. I'm sorry about that small mistake. I'm sure you've all spotted that. But basically, we need to show where we plan to have our sensors. That's part of the methodology. This is how we're going to do it. These are the types of tests that we're going to do. This is the extent of the test. So we plan to do a stability study in empty conditions with these sensor placements for 5 days, then we have 5 days of full studies. We plan to do a door opening test and a power failure test. And there we should mitigate all the identified risks. So if we take the door opening study, that's related to a risk that we've identified, that when you open the door for so and so long, because that's what we plan to do, there might be a risk of the temperature rising or falling for that matter without the accepted ranges. Well, if you can show that link for the reader of the protocol, especially if it's an auditor, you're really way off. You have a linkage between, you have a good understanding of your process and your equipment, you've identified the risks, and you've clearly shown that by doing so and so and so, you've mitigated those risks. That linkage is so important in terms of showing that you have a great understanding of why we map and how we plan to map. Typically, also as part of the methodology, just like to mention that you would often have the type of the sensor and the calibration. I'm not going to great detail, but often you'd want a calibration, or not often want to. You should have a calibration that covers your range of temperatures. So if you're mapping from 2 to 8 degrees, you might expect temperatures from 0 to 10. Well, you might say we have calibration points from -5, 5, and then what will that be? That will be 15 degrees. So it covers the entire range. We have some great articles on our webpage explaining this exactly. So I'm not going to bore you with all the details, but often you would also mention what type of sensors, because those could introduce risks. As you mentioned, an example of an autoclave. How exactly do you plan to place the sensors where they are, or in a larger warehouse? Exactly how do you plan to place the sensors? Often also what we'd see in a mapping protocol is the requirements for the reporting. How do you plan to report on your findings? So it's in my perspective, we should really be able to identify how should we communicate the results and what kind of results do we expect. I mean, there's various degrees of detail you could include, but often we'd want to see this is the contents, these are the topics that should be described in the report, and this is the format. Often we write as a report. That's often more than enough. And really, what results? Because we could use hours or weeks even doing data analysis and do all sorts of things, but having a baseline understanding or requirement for what should at least be in the report is a really good idea. It also gives, again, if you have two different people writing the protocol and one writing the report, I will always advise on those being the same person to give the most coherence and connection. But again, you could do that, and then having some expectations for which graphs, which type of visualizations would you want to import in order to be able to understand the results, right? Lastly, deviations. Nothing is perfect. Again, the real world hits, and basically we need to describe what will we do. And I've written purposely when something goes wrong, because I've yet to see the first mapping exercise that went perfectly smooth without any types of errors. Often it's very small ones or deviations that arise, but take it up front. What do we do if we lose 1 out of 600 data loggers? Is that fine? What about 6 out of 600? What about 50? We need to have some sort of limit, because when you're in there and the time pressure is on, it's so good to have a decision tree where you can just say, we can accept this, but not this. The same, again, who should be able to handle deviations and decide whether we need to do a remapping, and what are the limits for when we need to start over? Can we miss 1% of the data points? Is that fine? Of course, you can't always take into account all types of scenarios, but just having a basic understanding of the ground rules. So that really concludes the presentation here, but there are a lot of interesting questions Adam here has picked up on. So we'll basically get to the Q&A.
Right. Thank you,
yeah.
Jacob. Again, it's super interesting, and thanks for taking us through. I'd love to dive in to the questions.
Yeah,
but
absolutely.
And there's one question I have of my own until I dive into Francis and Mimit, who has super good questions, and thank you very much for that. Jacob, something that I note constantly is like the experience that you have, like some of the examples that you give, and some of, like, particularly all the big part about this, which is related to risk assessing everything.
Yeah.
much of it is also connected to your vast experience, like the thing you just said here in the end, which was like, so what happens if, that kind of question, like
Yeah,
what
yeah.
happens if 50 out of 600? I assume that we, again, because you said in the beginning that, that in the scoping part, that's there where
Mm.
people exceed, but on the experience part, typically that is
Yeah,
out there is low. So how do you actually balance that?
I would say that's also why we often like to describe the underlying risk assessments and how you should attack that problem. Because in my opinion, the guidelines are really due for review when they don't understand or explain. That's my own personal perspective. What are the risks that made them write these recommendations? And again, I would also go back to that and say, okay, in terms of experience, again, if there's an area of risk,
Mm.
you should mitigate that.
Mm.
And the same in terms of, you asked about deviations. Like the underlying question we should ask ourselves is, when I don't have this amount of data, that's often the case, will that impact my conclusion
Mm.
on the whether I say it's conformant or non-conformant? That's the question you should ask yourself. So going back to the question, like 1 out of 600 data loggers is missing, like it went missing or it was
Yeah, yeah,
destroyed, whatever it might be.
yeah, it happens.
Will that impact my conclusion where it was? Could we look at a sensor adjacent to that one? And
Mm.
but again, if it showed bad results, would that change my conclusion? So it's really about going back and saying, does this change my conclusion?
I'm just really,
Mm.
I admire,
Mm.
again, the real world experience that is a
Yeah,
big
yeah.
part of many of those parts in the risk assessments. But let that be. Um, Mehmet has a super interesting question. It's like, maybe we can just skip back a couple of slides here. I'm sorry to show this again, Jakob, with the OQ headline, but when I look at this and reflecting with Mehmet's question about, like, okay, so how do you actually handle a temperature and humidity mapping for a warehouse? Can you do it at the same time?
Well, that's not a major. Yes, the short answer is yes, but that's also when we measure relative humidity, we need to measure temperature. Relative humidity is a calculation, you could say, where you both include the temperature and the water vapor content of the air. So when you have relative humidity measurements, you do also have temperature measurements, and that's perfectly fine doing both of those. Often, what we tend to see is that a good rule of thumb is basically that if your relative humidity is critical for your application, 10% of the loggers could be measuring relative humidity as well. And you might say, why not all of them?
Mm.
Well, basically, humidity or water content in the air generally disperses and is way more mixed up than temperature is.
Because he also
Uh,
mentions, maybe, that he's from the medical industry,
yeah,
right? I remember, and I assume that's, packaging and stuff like that that's
yeah,
super
yeah.
influenced by it.
Often we see it in the GDP industries, like delabeling, for example, and also again with the acceptable ranges. Whereas temperature normally has a lower and an upper limit, relative humidity tends to just have an upper limit of, let's say, normally like 80% RH. And we tend to see as long as it's below that, it should be just fine. But then again, what do you do when we talked about humidity? Like, what do you do when you wash your floors? You will get deviations, sometimes smaller peaks where it peaks above 80%. And again, you might say, oh, we'll just not wash our floors during the mapping exercises. Well, then I would argue you have not done performance qualification, because washing your floors is a standard process in a GDP warehouse.
Mm.
So taking that up front and say, yes, we can accept high humidity levels for a maximum of 2 hours, for example, because it tends to, when we have final packing, it tends not to ruin the product just because you have 2 hours of relative humidity. But again, all processes are independent and really need to be taken into consideration independently.
Then I'm gonna take a question from Lee here that I'm gonna mix up a bit, because the question is basically, if like, how often do you need to perform a mapping in winter and summer? Every 24 months, every 36, as a periodic review? Is that part of the protocol process also?
No, I would say not normally. Normally, you would have a master validation plan in which you identify these, or a mapping strategy sometimes, even if we see that if a company does not have a whole lot of validation, like normally when you're a distribution company, for example, you would have a mapping strategy, so forth. the guidelines are actually quite clear on this, but it's just been misinterpreted and repeated over and over again with these exercises. So ISP guideline clearly states that you should perform mapping initially, following major changes, or, and there's a very important or in there, on intervals. It's the WHO guideline, I'm sorry. But there's a very important or in there. My advice is always, if there are major changes, perform it. And I'd often like to say that instead of having a remapping interval, have a re-review interval. So basically, once a year, review your logbooks, all the changes that have been performed to the fridge, freezer, warehouse, reefer, whatever it might be, and say, are any of these changes so significant, and how do they add to the overall risk that we might not be conformant anymore? Then, of course, there is a natural wear and tear on everything, on all sorts of technical installations. Insulation materials get degraded, HVAC systems get degraded, so forth, doors and gates. So in that situation, if you have had no major changes over the course, often it's recommended something either every 3 or every 5 years, really depending on usage. The WHO recommends between 3 and 5 if you do not have any intermediate due to major changes. Yeah.
Okay, so you can actually extend the revalidation of it if you do major changes.
And again, it's a risk based upon what's your risk appetite.
Right.
You might end up in a situation where you find out when you do the mapping that it was too late. So it's really also about risk appetite. Yeah.
Gotcha. All right. Well, I'm just gonna round out up now, because now it's just about ending. So maybe we'll just invite Frederikke into the room. Hi, Frederikke. And then I'll just ask the last funny question for you, Jakob, which is what is the equivalent of MKT for relative humidity?
I saw the question,
Have
and
you
I'm
seen
so
anything?
sorry, I don't have an answer. I've actually never considered
No,
this.
me neither. It's absolute humidity or something like that.
So just for as the very last answer here, MKT is mean kinetic temperature, and for calcul, it's a type of an average which takes into account the activation energy. So basically, you need to have an understanding of how susceptible your product, if that's the case, is to temperature changes. So I would assume it would be otherwise, because you would need the activation energy or an understanding of how sensitive those products are also to relative humidity.
Yeah, but I imagine that kind of energy changes when relative humidity changes. Because the air kind of like, there's a lot more energy
I
in
would
the
say
air when it's
in
humid.
absolutely the most cases, there are no problems with relative humidity. If there are any, you would install a dehumidifier, and that would take care of the problems. You should not have ongoing humidity issues. That should not be the case. Yeah.
Right. All right. Hi, Frederikke.
Hi. Hi, thank you for welcoming me back, and thank you for a great webinar. I just want to round everything off by saying thank you to everyone who tuned in to listen to all to all your clever words and observations. You will, yeah. It's great to hear from both of you, but thank you for taking your time also in the audience to ask a bunch of really great questions. We love the Q&A session. A little insight information is also that we'll be probably doing a lot more of that in the future with some Q&A sessions, and we look forward to inviting you again to those. So I just want to say thank you for participating. I will be sending you a participation certificate within the next couple of days. So stay tuned for that one. And you might see a few emails from me in the next week. I won't bother you too much, but I'll send you a certificate and thank you for participating. And yeah, so thank you so much, and have a great rest of your morning, evening, rest of your day.
Bye,
Bye.
everybody. See you. Thank you, Jakob. Hi, Frederikke.